Yeah. So good afternoon once again for all of you. So today we are going to look into a new chapter, okay, called alcohols, phenols, and ethers. So the last topic that we have seen in this Enable Plus program is haloalkanes and haloarenes, right? Which is an important organic chemistry lesson. And following that, this lesson is also will come under the organic chemistry only. Okay, so I have already told you that in class 12, we have 5 organic lessons. The second volume of NCERT book is full of organic only in class 12 chemistry. So you have to concentrate more on organic chemistry to get better marks in your NEET exam and your JEE exam. Got it? So let's go ahead with the session. So today we are going to first concentrate on the introduction to alcohols, phenols, and ethers. Okay. So coming to the introduction to alcohol. So what is an alcohol? So I have taken an aliphatic hydrocarbon here, and this compound is called as methane. Okay, it has 4 hydrogens, formula CH4, it is methane. So if one of the hydrogen is replaced by OH group, then the compound is the resultant compound is called as alcohol. Okay, so what is alcohol? Something with alkyl group attached to OH is called as alcohol. Got it? Now, what is a phenol? Phenol is derived from basically from benzene. So, benzene means C6H6. Okay. So, in benzene, we have 6 hydrogen. If one of the hydrogen is getting replaced by OH, then we call the compound as phenol. Okay. C6H5OH is called as phenol. And then coming to ether. So to derive the ether also, I have taken a hydrocarbon and replaced one of the hydrogen by one OR group. OR means alkoxy. Okay, R group can be alkyl, CH3, C2H5, can be anything. But if you replace H by OR, you will get an ether. Got it? So what is an alcohol basically? ROH. ROH is called as alcohol. Okay. So phenol means C6H5OH and ether means ROR. Both alkyl group can be same or both can be different. Okay. One is taken as R and the other one is taken as R dash. So it is up to us. Got it? So in this lesson, we are going to learn about these 3 compounds only. Okay. So now, before moving on to the concept, we should ask this question to ourselves, right? So why do we need to prepare or why do we need to study about alcohols, phenols, and ethers? So that should be some applications, right, for the compound which we are forming. So the main application is the industrial application. The OH containing compounds have several industrial applications. Okay. So like in case of the check, the paper which is prepared for making the checks and for notes, okay, rupees notes, and for papers, cards, okay, newspapers, cards, and the cotton also. So all these materials have the compound alcohol and phenol. Got it? Coming to ether, so ether is present in the medicine which is given for anesthesia. Got it? So ether is a good anesthetic agent, I can say. And ether is also used as a solvent. Like in case of nail polish remover, in case of paint remover and all, if you see, ether will be one of the component present in that solvent. Got it? So because of these applications, we are learning about these 3 compounds. All right. Shall we go into the lesson now? So this is the introduction. This is the introduction to this lesson. So now we will enter into the main part of it. So the first main topic is classification, nomenclature, and structure. Okay. So under this, we are going to discuss the classification of all the three compounds, nomenclature of all three, and the structure of all three. Got it? So let's move into the classification of alcohols, phenols, and ethers. So I will move on to the classification of alcohol first. So first of all, it is classified into three according to the number of or based on the number of OH group present in the compound. It is classified into three. So the first is monohydric. Mono means one, right? So if only one OH group is present in the compound, then it is called as monohydric alcohol. Okay. So for example, C2H5OH, which is called as ethanol. So this ethanol has only one OH group present inside it, right? So it is an example for monohydric alcohol. Then the second classification is dihydric. Dihydric means two OH group will be there in the compound. Okay, so I will take an example. Ethylene glycol is taken. So ethylene glycol is a single compound, but in that single compound we have two OH group. Got it? So it is an example for dihydric. Then the third classification is trihydric. Tri means three. So if three OH groups are present in one compound, then it is the example for trihydric compound. So these are the three main classification. Lastly, we have one more also, which is called as polyhydric. Poly means many. If many OH groups are present in the compound, it is called as polyhydric. Okay, so sorbitol is taken an example, and in sorbitol, you can see that there are 6 OH groups present in the compound. Okay, so this is the first classification which is based on the number of OH groups present. Clear? So now, do you have any doubts here in this classification, students? Shall I go for the next slide? Everything is clear till now, no? Do you have any doubts, students? Shall we go for the next? Shall we go for the next? Okay. So now, okay, great. So now let me take this monohydric. Okay, so let us study about the monohydric alcohols. Now, based on the hybridization, now I am going to classify this monohydric alcohol into two based on the hybridization. Okay. So based on the hybridization, first I am going to classify this with sp3 hybridized system. Okay. Compounds containing carbon as sp3, which is attached to OH bond. Got it. So I will take one example. CH3OH. So here if you see, the OH is attached to the carbon which is sp3 hybridized. So how I am saying it is sp3 hybridized? Because it has only single bonds around it. Okay, so there is no double bond or triple bond. So the carbon is an sp3 hybridized carbon. Got it? So the OH is attached with the carbon which is sp3 hybridized. So it is an example for this. Got it? Now, this sp3 hybridized system itself is having three types. One is alkyl alcohol, the second one is allyl alcohol, and the third one is benzyl alcohol. Okay, and each will have primary alkyl alcohol, secondary alkyl alcohol, and tertiary alkyl alcohol. So in haloalkanes, haloarenes lesson itself, we have studied, right? So what is meant by primary, secondary, and tertiary and all. So here also I will try to explain. But first of all, let's complete this classification. So this is all about the sp3 hybridized system and its classification. Got it? And the second type of monohydric alcohol based on hybridization is compounds containing sp2 hybridized carbon which is attached to OH bond. Okay. So let us take an example. So here I have taken this compound as an example. And if you see, the OH is attached to the carbon which is having double bond. OH is attached to the carbon which is having double bond. So the hybridization of the carbon which is attached to the double bond is sp2. Okay, the OH attached carbon is having sp2 hybridized carbon. Got it? So this is again classified into vinylic alcohol and arylic alcohol, but that arylic alcohol will come under the classification of phenol. So let us take this vinyl alone. Got it? Clear up to this? So what we have done? We have took the monohydric alcohol. So now based on hybridization, it is getting classified into two. One is sp3 and the other one is carbon with sp2. So under sp3 we have three classification and under sp2 we have only one classification, only vinylic alcohol. Got it? You all know what is meant by vinyl, right? So carbon will have double bonded carbon and that will be directly attached to OH. If this OH is H, then it is called as vinyl halide. So that is what we have discussed in the previous lesson. Now instead of that halogen, we have OH group. So it is called as vinylic alcohol. Clear? So any doubt? Shall I go into deep about this alkyl alcohol? Shall we enter into the classification of sp3 hybridized system in detail? Do you have any doubts till this? Students, shall we go ahead? Okay. So the next is alkyl alcohol. So I told that each subdivision is having three types, right? If I'm taking alkyl alcohol, it has primary alkyl alcohol and also it has secondary alkyl alcohol and also it has tertiary alkyl alcohol. Okay. So what is meant by primary alkyl alcohol? It is denoted by 1 degree. Okay, primary alcohol is written as 1 degree and the formula will be RCH2OH. Okay, so CH3OH is actually called as methanol, right? We have only one carbon. So it is methanol or methyl alcohol. So if I replace one of these hydrogen by one R group, it is called as primary alcohol. So in primary alcohol, we will have CH2OH group. Okay. And in case of secondary alcohol, the second hydrogen of this will also get replaced by alkyl group. So what we will have? We will have R2CH. R2CH and OH. And in case of tertiary alcohol, the third hydrogen will also get replaced by the alkyl group. So I have R3COH. Okay. So primary means CH2OH containing compound. Secondary means CHOH. And tertiary means it is COH containing system. Okay. Now let's see some examples under each case so that you can understand this better. So here you see I have OH and this OH is attached with CH2 and this is the R group. This is the R group. Can you able to understand? So alkyl alcohol is actually the classification under sp3. So the OH attached carbon is having sp3 hybridization and the R group here is CH3. Okay. And coming to secondary alcohol, OH is attached with sp3 hybridized carbon. Okay. And these two groups are the alkyl groups. Okay. R2CHOH. Okay. And here you can see OH is attached with sp3 and the three alkyl groups are here. 3 CH3 groups are attached. So we have only COH component here. So which is an example for tertiary alcohol. Okay. So these are the three types of alkyl alcohol. And the second classification is allyl alcohol. Right. So coming to the allylic system, So what is meant by allyl? The OH group is attached to a sp3 hybridized carbon, which is adjacent to the carbon-carbon double bond. Which is adjacent to the carbon-carbon double bond. OH is attached to an sp3 hybridized carbon, which is adjacent to a carbon-carbon double bond. So, basically, we have 3 carbon. Basically, we will have 3 carbon. And those 3 will be arranged in this manner. Carbon, double bond carbon, single bond carbon. And that single bonded carbon will be attached to the OH group. Okay. So in the previous lesson, that OH group was halogen and here it is OH. That is the only difference. So in allylic also we have primary, secondary and tertiary. Let me go into the primary alcohol. 1 degree, primary alcohol. So CH2 double bond CH, single bond CH2 OH is the example for primary. Now how to get the secondary alcohol? Primary means we will have CH2OH component here. To get the secondary alcohol, what I have to do? Here I have 2 hydrogens, right? The sp3 hydrogens. sp3 carbon containing hydrogens. So among those 2 hydrogen, one should be replaced by some alkyl group. By doing so, we will get the secondary alcohol. So in secondary, we will have only CHOH. Okay. Now, if you replace the third hydrogen with some other alkyl group, you will end up with the tertiary. So here you see, we have only COH. All the remaining parts are alkyl parts and the double bonded carbon parts of allylic system. Clear? Able to understand? Can you all able to understand? Do you have any doubts till this? Allylic system students? Madhukar Reddy, Bishan, Hemachandra, Rakshit Kumar, Jain Viroing. Do you have any doubts here? Everything is clear so far? Shall I go slow, little bit slow? Okay. If you want me to go a little bit slow also, just let me know, okay? It is okay, right? Fine. Okay. So what is the third classification? Under sp3, alkyl is over, allylic system is over. What is the third one? Can anyone tell me? What is the third classification under sp3 hybridized classification? Yeah, very good, Rakshit. It is benzylic alcohol, right? Great. So, benzylic alcohol means the OH group is, yes, yes, Bishan. Great, great. OH group is attached to a sp3 hybridized carbon atom next to an aromatic ring. sp3 hybridized carbon atom next to an aromatic ring. So, what is an aromatic ring? This is an aromatic ring. And this aromatic ring has carbon, okay, and to that carbon OH will be attached. Now you read the statement, OH is attached to an sp3 hybridized carbon atom which is next to an aromatic ring. Got it? So here I may have CH2 and I may have CH or I may have only C. So that is what I'm going to classify now. To get the primary alcohol, primary benzylic alcohol, I will have CH2OH. And to get the secondary alcohol, what I will have? I will have to replace this hydrogen by one of the hydrogen by alkyl. So I will have only CHOH, which is secondary. And this is the alkyl group. All the things can be hydrogen or we can still classify this. And for tertiary, I have only COH. Okay. So this part is one alkylic part and this is another alkyl part. Okay. So this is an example for benzylic system. Benzyl means you should know it is C6H5CH2. Okay. Or CHR or CR2. So this part is called as benzyl. This part is called as benzyl. And some students will get confused confused with the benzyl and the phenyl. Phenyl means you will have C6H5 bond. That's all. Okay. So this is called as phenyl. Clear? So what is phenyl? C6H5 bond is called as phenyl, and C6H5CH2 bond is called as benzyl. Clear? Able to make the difference between benzyl and phenyl? So you should not make any mistake when I ask you to give me the formula for phenyl and benzyl. Okay? In benzyl, CH2 will be there. In phenyl, we will have only C6H5. All right. Can you all able to understand the definition and the classification of alcohols? Shall we go into the classification of phenol? Say yes or no. Shall we go into the classification of phenol? Okay. So coming to the classification of phenol, phenol is also classified according to the number of OH groups present inside it. Okay. As monohydric, dihydric and trihydric. Mono means only one OH will be there and the examples phenol. Dihydric means there will be two OH groups. So here you can see the two OH groups are adjacent to each other. If they are adjacent to each other, then it is called as catechol. Okay. If the two OH groups are alternative to each other, then it is called as resorcinol. If the two OH groups are opposite to each other, then it is called as quinol. Okay. So, these three will come under the dihydric category. And trihydric means there will be three OH. Okay, if all the three are adjacent to each other, it is called as pyrogalol. And if all the three are alternative with each other, then it is called as fluoroglucinol. It is called as fluoroglucinol. Okay. So very easy. So this classification is based on the number of OH groups present inside the system. Okay. So this is all about the classification of phenols. Nothing much to study here. Now, next I will enter into the classification of ether. Okay, I hope all of you can able to understand this classification of phenol. So I will enter into the classification of ether. Now, ethers are classified into two. Okay, one is simple or symmetrical ether, and the other one is mixed or unsymmetrical ether. Simple or symmetrical, mixed or unsymmetrical. Okay. So what is meant by a simple ether or what is meant by a symmetrical ether? They are the alkyl or aryl groups attached to the oxygen are the same. Okay. If the alkyl groups attached to the oxygen group is same, then it is called as a simple ether or symmetrical ether. So what is the general formula for ether? It is ROR, right? If the two R groups are same, so here in the example you see two R groups are CH3. CH3 means methyl. So it is called as dimethyl ether. So it is an example for symmetrical ether. Okay. And if in the second example you see, we have two phenyl groups. This is one C6H5 and this is another C6H5, which is called as phenyl. So diphenyl ether is an example for symmetrical or simple ether. Okay. If the two alkyl groups attached to the oxygen are different, if they are different, then they are called as mixed ether. So here you see, I have one CH3 group and one C2H5. So this is ethyl and this is methyl. So according to the alphabetical order, E comes first. So it is called as ethyl methyl ether. Okay. So if the two alkyl groups are different, they are called as unsymmetrical or mixed ether. And the second example, we have phenyl and we have methyl. So phenyl methyl ether. Okay, this is called as phenyl methyl ether. This is an aromatic compound, right? So it is taken as a first priority. So phenyl methyl ether. So now this is all about the classification. Now let's do one question based on this. Okay. So I have taken 4 compounds for you. You have to classify these 4 compounds as primary, secondary, and tertiary. So can you guys try for the first one? Can you classify? Okay, I will do for the first compound. You try to do for the from the next compound onwards. Okay. So let me take the first compound. So here, this group is taken as a complete R group and that is attached with CH2OH. So it is a primary alcohol. It is an example for primary alcohol. So can you guys tell for the second compound? Can you tell me whether it is primary or secondary or tertiary? So OH is attached with CH. So under which classification you will classify? Very good. It is secondary because carbon is having 2 alkyl groups. Very good, very good. Very good, students. It is secondary. What about this third compound? Let me see who is going to give the correct answer. Yes. Yes. And also one more question I want to ask. It is a tertiary alcohol. It is an example for tertiary alcohol. Can you tell me it is it is tertiary alkyl alcohol or tertiary allylic alcohol or tertiary benzylic alcohol? Under which classification it will come? Tertiary alkylic, tertiary allylic and tertiary benzylic. So which is the correct answer? Very good, Rakshit. It is tertiary allylic system. Yes, yes. Good, good, Bishan. Tertiary allylic system. Great. What about the fourth compound? Secondary? Okay. Secondary alkylic or allylic or benzylic? Secondary alkylic or allylic or benzylic? Sure? Okay. So it is secondary benzylic because OH is attached to the carbon which is directly attached with the aromatic ring, right? So it is an example for secondary benzylic alcohol. Very good, students. So you all have understood the classification very nicely. So now let us go for the second topic, which is nomenclature of alcohols, phenols, and ether. Okay. So let us go for the alcohols nomenclature first. So what is meant by nomenclature? Naming, right? So we are going to name the organic compound with the 2 different types of name. One is called as common name and the other one is called as IUPAC name. So let's go for the common name of the compound first. So the skeletal structure for common name is, first you have to write the name of the alkyl group and then you have to add alcohol to it. Okay. For example, if I have CH3OH. So what is the name of this CH3 which is an alkyl group? Can anyone tell me the name of this alkyl group? CH3. What is the name of this alkyl group CH3? If I have only one carbon in the alkyl group, then it is called as methyl, right? So CH3 is called as methyl. And to this methyl, you have to add the word alcohol. So what is the name of this compound? Methyl alcohol. It is called as methyl alcohol. Okay. So what about the second compound? I have 2 carbon, C2H5. If there are 2 carbon, then it is called as ethyl. So the name is ethyl alcohol. Got it? And what about this? Here I have 3 carbon, CH3, CH and CH3. Okay. So if these 3 are arranged in a branched manner like this, it is called as isopropyl. This is called as isopropyl. Okay. And here 1, 2, 3, 4, 5 with one branch kind of thing. So it is pentyl alcohol. It is called as pentyl. 5 means pent, right? So it is pentyl alcohol. So this compound is also having 5 carbon, but the arrangement is different. Okay, single carbon is attached with 4 other carbon. So this group is called as neopentyl. So the name of this compound is neopentyl alcohol. Okay, this is just normal pentyl alcohol and this is called as neopentyl alcohol. The formula will be same for this 4th compound and the 5th compound, but because of the different arrangement of carbon atoms, the name is different. Okay, and coming to the last compound here we have phenyl. Okay, phenyl, and this phenyl group is attached with the 2 carbon containing alkyl. 2 carbon means ethyl and this is phenyl. So it is called as phenyl ethyl alcohol. Okay, phenyl ethyl alcohol. Clear, students? Can you all able to understand the common names of the alcohols? Do you have any doubt? One carbon means methyl, 2 carbon ethyl, 3 carbon propyl, 4 carbon butyl, 5 pentyl, 6 hexyl, 7 heptyl, 8 octyl, 9 nonyl and 10 will be decyl. Okay. So you have already studied, I think, not I think, this particular alkyl group concept is already there in your class 11. You all have studied that, right? The name of the alkyl group and the formula and how to find out the things and all. Yes or no? In some basic concepts of organic chemistry lesson, you might have studied in your previous year. Yes. Yes, right? Yeah. So, any doubt here? Shall we go ahead? Shall we go ahead? If you say yes, I will go ahead. If you keep quiet, then I cannot go ahead, right? Can you all able to understand? Okay, fine. Good. Yeah. Thank you. So now let's go into the IUPAC nomenclature of alcohols. So in IUPAC nomenclature, what we have to do, we have to use the suffix OL. Where we have to use the suffix OL and how to use OL. So if, first of all, you have to take alkane. You have to write the name of the alkane and you have to replace the E by OL. So what you will have? Alkanol. The name of IUPAC system is alkanol. I will take the same compound. Let me take the same compounds. First one is CH3OH. And what is the name of this alkane? Since I have only one carbon containing group, it is called as methane. It is called as methane. If I replace this E by OL, what I will get? Methanol. So the name of the compound is methanol. And here C2 means 2 carbon means ethane. If you replace the E by OL, it is called as ethanol. Okay. And the third compound. So here for the compounds which is having more than 2 carbon, for the compounds which is having more than 2 carbon, we have to start numbering the carbon atoms. So that is the rule, right? It is one of the IUPAC rule. So here, this compound is having 3 carbon. So what I have to do, I have to start numbering. So since this compound is symmetrical, you can number from either way. You can go from left to right, or you can go from right to left also. So let me go with this type of numbering. I have gone from right to left. Okay. So now to the second carbon, since this compound is having 3 carbon, it is the name of the alkane is propane. Name of the alkane is propane. Okay. But we also have OH here, right? And that OH is attached to the second carbon. So what I have to do? I have to replace this E and I have to mention the number of the carbon to which the OH is attached. So it will be propan to all. Propan to all. The alcohol is attached to the second carbon. That is the meaning. Okay. So can you guys try the number for this compound? Can you guys try the name? Not number. Can you go for the name straight away for the fourth compound, which is called as pentyl alcohol in common type of nomenclature? What is the IUPAC name of this pentyl alcohol? Can anyone try the answer for this? So we have 5 carbon. Very good, Bishan. We have 5 carbon and all the 5 are numbered in this manner because it is not symmetrical. Pentan to all is the correct name. Yes. It is not symmetrical. So the OH attached carbon should be given the first preference. Okay. So that's why left to right numbering is preferred here. If I start from right to left, I will get the number 4 to the carbon which is attached with OH. That is incorrect. OH attached carbon should get the first priority. So that's why left to right numbering we have done. Now the name is pent. 5 carbon means pentane, right? So in pentane, you have to replace the E by 2OL. So it is pentan 2-ol. Okay, good. Let's go for the next. What about this? So here we have lot of branches, right? So first of all, you need to find out the parent chain. Parent chain means the longest carbon containing chain, more number of carbon containing chain. So which is the longest chain here? And that longest, more number of carbon containing chain should have OH in the as a component. Okay. So the straight chain is the parent chain because there we have more number of carbon as well as the OH group. Okay. So now you have to start numbering. The OH attached carbon should get the first preference. So 1, 2, 3. I have numbered. Now what I have to do? Now, yeah, exactly correct, Bishan. Exactly correct. So now we have to look for the substituents. So we have 2 substituents, methyl. Both of them are called as methyl. Both of them are attached to the second carbon. So what I have to do? 2, 2, dimethyl, 2, 2 dimethyl, and straight chain has 3 carbons. So propan, and to the first carbon OH is attached. So propan 1-ol, 2, 2 dimethyl propan 1-ol. Okay. 2, 2 dimethyl propan 1-ol. So this is the prefix. Okay, alkyl group is a prefix and prop is the root word and this OL is the suffix. Got it? So the IUPAC nomenclature should have a prefix, root word and the suffix. So prefix can be all the substituents and the root word is the alkane. Okay. The methane, methane, ethane, propane, that alkane name should be written in the root word and suffix will be the functional group which is there. All right. So let's move into the next compound. So how to name this? which is the parent chain. Parent chain cannot be the aromatic ring. Okay, so we have two carbons, right? So those two are taken as a parent chain. And to the first carbon, we have an alkyl group. Like this CH3, I have this phenyl C6H5. Okay. So the phenyl is attached with the first carbon. So it is one phenyl and two carbons are here, no? So one phenyl, ethane, two carbon means ethane. And to the first carbon, we have OH also. Ethane or ethane, one all. Okay, one phenyl, ethane, one all. Okay, clear? Do any of you have doubts here till this? You will get used to it when you practice this nomenclature. Okay, don't worry if you feel this difficult. Please go through and take more number of problems from your book or the modules and practice it. It will be very easy for you. Okay, don't worry now. Shall we go for some more examples from this type? Are you ready to solve the nomenclature? Yes. Start naming this compound. And this compound has two OH groups. Okay, I will try for this. Okay, I will try this from next compound onwards. You can try. Since this compound has two OH groups, I am going to try. Okay. So number the carbon ring will be from left to right because OH attached to carbon should get the first preference. Now, since I have 5 carbon, it is pentane. And to the third carbon and to the second carbon, we have alcohol. Yeah, Bishan, your answer is exactly correct, but there is one small mistake. Can you find out that? We have 5 carbons, so it is called as pentane. And 2 OH are there. One is with the second carbon and the other one is with third carbon. What we have to do? No, it is not pentene. Jane Viroing, it is pentane only. But we have to replace the E. We should not write the E here. It is pentan 2,3 diol. Pentan 2,3 diol. Okay. Clear? You have written E over there, and that is the small mistake you have made Mission. And Jane Viroing, it is not pentene, it is pentan, T-A-N. Okay? Can you both able to understand? Okay, I will go for the next compound. Yeah. So what is the name of this compound? Here I have a ring. Just a cycloalkyl ring I am having. And in the ring I have 6 carbon. In the ring I have 6 carbon. 1, 2, 3, 4, 5, 6 carbon I have. So it is called as cyclohexane. It is called as cyclohexane 1 all or cyclohexane. We have only one OH, right? You can put the number 1 or you cannot write that. For 1, there is an exception. You can write or you don't have to write. Okay. So it is cyclohexanol. Cyclohexanol. Now I will go for a little bit big compound. Let's see who is going to give the correct answer for this. Straight chain is the parent chain because it has more number of carbons and also OH group. Okay. And next we have to start numbering, right? So OH attached to carbon should be numbered 1. So I have number also. Can anyone give me the name of this compound? We have 3 substituents. One is chloro and the other 2 are methyl. So what is the correct name? What is the correct name, IUPAC name of this compound? We have 3 substituents. One is chloro and the other 2 are methyl. So find out the correct name of this compound. If we have more than one type of substituent, then we have to name the compound in terms of alphabetical order. Okay. So we have C for chloro and M for methyl. So which comes first? C or M? Which comes first in the alphabet? C, right? Very good. It is 4-chloro, yeah, 2,3 dimethyl, pentan, 1 all. Okay, so that you should not leave any gap in between the names. Okay, it is a single name. So please don't leave any gap. Okay, it is a single name. Very good. Very good, Rakshit Kumar and Bishan. Great, great. Both of your answers are correct. So you can also write 4-chloro 2,3-dimethyl pentanol. Since one is there, you can write that one or you don't have to write that one. Okay, both the names are correct only. So all of you try for this last compound. So here we have one substituent, right? What is the name of this substituent? It is one carbon. It is CH3. So start naming this. We have to first number, right? How will you number? Clockwise direction or in anti-clockwise direction? OH attached carbon should get number 1 or CH attached carbon should get number 1. Yeah, very good. OH attached carbon should get number 1 and this CH3 is taken as number 2. The name of the compound is 2-methyl cyclopentan 1 all. Very good, very good. 2-methyl cyclopentanol. 2-methyl cyclopentanol. Because in the cycle we have 5 carbon, right? So it is cyclopentane. And in the second carbon we have methyl. So it is 2-methyl cyclopentanol. Very good. So this is all about the nomenclature of alcohols. Any doubt from the nomenclature of alcohols for anyone? Shall we get into the nomenclature of phenols? Are you ready? Any doubt so far? Okay. So the next is nomenclature of phenol. So let's go into the common name as usual. Okay. C6H5OH, this is a very common example and this is phenol, right? If OH is attached to the phenyl ring, it is phenol. If one CH3 and one OH are adjacent to each other, okay, CH3 and OH, if they are adjacent to each other, this will come under a family called cresol. This will come under a family called cresol. Since they are adjacent means ortho. Adjacent means ortho, right? So this compound is called as orthocresol. This is called as orthocresol. If the same CH3 and OH are in alternative position, that is if they are in meta position, it is called as metacresol. If they are opposite to each other, it is called as para. So this is called as paracresol. Okay. So in the last 3 compounds, we are talking about CH3 and OH group containing system. Okay. So all this is coming under a family name called cresols. Okay. Adjacent means ortho. Alternative means meta. Opposite means para. All right. Now I am going to take one more type of system in which I have 2 OH groups. If 2 OH are present in adjacent position, it is catechol. If they are alternative with each other, it is resorcinol. If they are opposite to each other, it is called as quinol. Already we have studied about these 3 compounds in the classification, right? So the same is coming here in the common name also. Catechol, resorcinol, quinol. So we don't have any common, family names for this OH-OH combination. Each one is having a different name only. Okay, but for CH3 and the OH combination, we have a family name called cresols. Clear for all of you? So this is the common name for some of the phenols and its derivatives. Now we will go ahead with the IUPAC nomenclature of all these compounds. Okay. So for phenol, according to IUPAC also, we have to call the phenol as phenol only. C6H5OH is called as phenol only. If I go for orthocresol, I cannot name this as orthocresol again, right? Because according to the IUPAC, if there are more than one substituent, we have to number the atoms, right? The OH attached carbon should get number 1 and the methyl attached carbon. So now we have methyl group in the second position. So it is called as 2-methyl phenol. 2-methyl, and this part is called as phenol, right? So it is 2-methyl phenol. What could be the name for this compound, students? If it is numbered like this, what is the name? Very easy, right? It is, try the name for this compound. Very easy. So in the third carbon, we have the methyl group. So what is the name of this compound? What is the name of this compound? Students? Yes. Great. 3-methyl phenol. And the last one is 4-methyl phenol. Okay. Then if I come to this catechol. Catechol is the common name of this 2 OH, adjacent OH attached compound. But still I have to number. Even though both of them are OH, still I have to number. Okay. So this part is called as, taken as benzene. It is benzene 1,2 diol. Okay. And this is also called as 2-hydroxyphenol. One of the OH is taken as hydroxy and the other one is taken as the phenol. 2-hydroxyphenol. And this one is benzene 1,3 diol or 3-hydroxyphenol. The last one is benzene 1,4 diol or 4-hydroxyphenol. Both of them are correct only. But the more appropriate answer is the one which is given in the red color. Okay? Clear for all of you? Any doubt? Any doubt from this for anyone? Shall I go for the nomenclature of ether and complete the class today? Or we will look into the nomenclature of ether in the next session? What do you guys say? It is 5:03 now. The timing is 5:03. Shall we look into the nomenclature of ether today or in the next session? What is your answer, students? Tell me first. Okay. Fine. So I hope you have understood the classification and the nomenclature of alcohols and phenols from today's class. So tomorrow we will look into the nomenclature of ethers. Okay. So thank you so much for attending the class and see you all with the next set of concepts in the next session. Rakshit, we are running out of time now. So we will look into the nomenclature of ether tomorrow itself. Okay. Tomorrow we have the class, right? So tomorrow we will look into it. So before leaving the class, I would like to launch a poll regarding the feedback of the class. You can give your answers over here and then wind up the call. Okay. Thank you so much, students. Thank you.